MAP4C, day 42, lesson 5.1, the first lesson in Unit 5. Unit 5 is called Graphical Models. When we're talking about a graph here, we're not talking about like a bar graph or a pie graph or something like that. We're talking about, a math graph, the graph of a function, like the one we see here. And so we're going to be talking about those sorts of concepts in this chapter. The 3-minute review is just to get us going here. A review goal, and also from time gone past. Interpret graphs to describe a relationship. What's the independent variable? Well, that's review. It's time. What's the dependent variable? It's distance from home. And what story does this tell? Well, we see that the two are changing at the same time. So I could say, as time increases, well, what happens to distance from home? It goes up. Distance from home also increases. There's a problem here. Well, that's good enough. This is what we're expecting at this point. But there's a problem with this, because if I had a couple of different graphs, like say this one, or this one, this is still time, and this is still distance. How would we tell the story for this one? We'd say, as time increases, distance from home increases, which is exactly what we said about that graph. Even this one, which looks a lot different, as time increases, distance from home increases, and that's exactly what we said about that graph. We want to be able to distinguish between these three graphs, and we will. 5.1, trends in graphs. Expectations. Interpret graphs to describe a relationship. It says a part of a graph can either increase, decrease, or stay constant. And the graphs we'll be looking at may contain all three parts. So here's a little sketch. And we'll see it can be any variables. Our example in the 3-minute review was time and distance from home, but it could be anything. See here. So for instance, it could increase, it could decrease, or it could stay constant. Right? Well, that's increasing. This first part is increasing. This second part is decreasing. And the third part is staying constant. Well, you might say, you just made that up. That's never going to happen in real life. But if you think of the variables, maybe time and height of a golf ball. So the height increases, gets to as high as it's going to go, then it starts decreasing, then it lands wherever it's going to land, and it stays at that spot. Right? So this is height of a golf ball, and this is the time that's gone by. So certainly it's possible to have a graph like that. Each part could be described more precisely. Now this is what we were talking about before, where we said all of these look like as x increases, y increases, as x increases, y increases, as x increases, y increases. But let's be more clear. In this case, notice it's going up by the same amount each time. For each bunch of x, it's going up the same amount. So we can say as x increases, y increases at a constant rate. Other words you might think of as a steady rate or something like that. For this one, as x increases, y increases, but let's be more precise. It's increasing really slow at the start and then more quickly at the end. So we can say that increases slowly at first, and then more quickly. Well, what would that look like? Notice that if I'm thinking of maybe it's 1 hour gone by, there's maybe 1 hour. At the start, the distance from home is only changed a little bit, and that's supposed to be the change in y there. Where at the end, the same horizontal distance, the same hour that's gone by, the distance from home has increased by a whole bunch, right? So it increases slowly at first and then more quickly. And the last one is the opposite, right? Increases quickly at first, but then more slowly. Do over. Quickly at first, then more slowly. And if I think of my hours, there's an hour gone by, 1 hour gone by, and where's the distance from home changed? It's not exact, but I can see it's went up by a lot. But down at the end, 1 hour's gone by, and the distance from home has changed very little. It's very slow. Fast and slow, there's more slow than fast. Here's an example, pulled from the internet somewhere. Trends in current cigarette smoking among high school students and adults in the United States. So this is American data, but I think the Americans and Canadians are pretty close on their percent of people who smoke. Fairly close. Describe the trend for adults. So this one is the trend for adults. And notice that it's a pretty steady decline, right? So if I wanted to describe it, I'd say, you know, in 1965, starts at maybe 42% started. This is the percent of people who smoke. Start at 42% and decreases as it's going down at a fairly steady rate. Fairly constant rate. Describe the trend for high school students. Well, kind of looks like it goes up for a bit and then down for a bit and then I guess it up and then down, but this little stuff on the end is only a few years at a time. Let's think of that as one piece. So I'm going to actually break this graph into 3 chunks, and I'm going to say this first chunk is going to be a statement, the second chunk, and then the third chunk. So this first chunk, notice that it goes up quick and then slow. So for the first part, the percent, and I'm going to, after this, I'm not going to write this in, of high school students increased quickly, then more slowly. And notice I can be as precise as I want to be. This is from about 1991 until maybe 96. About, reading that from the graph. And then the second piece here, it decreases slowly and then more quickly. And I could start with, maybe I'll start with my from here, just to change the English. From 1996 to, what's that, 2003, the rate, or the percent, maybe it's a percent, decreased slowly, then more quickly. And I said that I could bust this up, but it's going downhill, and I'm going to say it's a fairly steady rate, okay? Then since 2003, the high school student rate has decreased fairly steadily. Okay. See how sort of much more detail we need to put on when the graph is changing that much. It says predict the changes for 2020. Well, I'm going to do this in two different colors here. This one, I'm going to see if I can find a line that kind of follows the trend of the adult. And it's kind of like we got to move on from where the trend was so far. I'm going to change the color here. Maybe it's purple. And then find in 2020 what that amount might be. Up from 2020 over, how much is it? Maybe 15? It's kind of hard to read. Yeah, maybe 15 for adults. And again, I just extended my graph. So the adult percent is about, that's the little symbol for about equal to 15%. Where, is that green or yellow? Green maybe, okay. If I were to sort of extend this, maybe try and get a, kind of looks like, I'm going to get my other line out of the way. Hopefully you haven't messed up your graph too much. Does that look like the trend? Yeah, not bad. It looks like at some point in the next few years, might be even steeper than that, the percent of high school students is going to get lower than the adults again. And then maybe in 2020, it'll be a lower amount. Now this is just an estimate, isn't it? Oh, that's a terrible color. There, that's pretty close. And we're just extending the graph. High school student percent about, well, in 2020, what would we say? A little bit lower, maybe 13%. These are just estimates, just using the trend and coming up with an estimate. About 13%. And of course, these are all open to debate. Don't yell at me. Yell at your partner about what they think, okay? And if you change the slope a little bit, that'll change your answer. Lots of questions like this in the homework. Have fun with that. That's it for today. Stay classy, Northwestern.